You decide to construct a 95% confidence interval to see if the observed difference is significant. So it's difference.
Right. Which
So
was
that one. I think I put independent samples on that one. You have the psych majors that were satisfied and the accounting majors that were satisfied. And you're comparing the difference.
right.
Difference, we did, it would either be paired or independent, right? Can't remember.
I'm trying to figure out. No, I'm looking at the lesson 17, but I'm not sure.
Confidence interval for one proportion or two proportions. Let me see. Let me go to the textbook. Hang on. Okay. Computer's going so slow. Okay, so I don't think that I don't think it's proportions because we don't have enough numbers, you know, it would be like this many total and this many qualified for each each section.
Yeah, that's what I was just reading, and I didn't really see anything that stood out to me in that.
So I think maybe it would be maybe independent samples. I think maybe it's D because it's still two populations that we're looking at, but they're not dependent on each other.
Right. That would make sense.
Okay.
That sounds good to me.
The next one for the Oreos. I think I put, it says what you're trying to find is you want to estimate the true mean filling amount in order to compare it to the filling amount in regular Oreos. So I thought that was a one sample T. What do you think?
Sorry, you cut out with what you were saying. I feel like I was just reading this. Take a sample of the 55. Where was I reading that? Is that one sample proportion? I don't know.
That's what I was thinking. We'll just do B on that one.
Okay. Or wait, or is it two proportion? I don't know.
Well, you're only trying to find out for double stuff, and then you'll compare it to the regular, it said. So.
Oh, okay.
I think it's one.
Yeah, that works then.
Okay, so for the next one, significance level is the probability of a type 1 error, right?
Yeah.
And then the next one, the definition of p-value is the second one. It's the probability of observing a statistic more extreme than the one actually obtained.
Right.
And then 11, I put the last one.
Yeah, because I remember seeing that one on the quiz a few times.
Mm-hmm. Yeah, they're getting tricky because they're putting stuff from the other chapters in
I
here.
know.
All right, and then this one, if p equals 0.30, then the mean of the distribution is also 0.30, right?
Right. Yeah.
And then the standard deviation I calculated out as 0.0458.
0.0458. So
0.046, I guess. Right?
Yeah.
Because it would
Yeah,
round
because
to
it's
5, would round to 6.
0, right? Yeah.
Yeah, 0.0458. And then 14, the probability that I got was 0.1376, so it would be the first one.
Okay.
Hopefully I got it right.
Those sound familiar to me, so I just wish I had my paper to double check.
I know. I'm sorry.
It's all good.
So the next one, I got the last one, negative 0.04 and 0.29.
Okay.
And then the next one, I got the second one, because the null is P1 equals P2, and the alternative, it says we want to find if it's different, right?
Right. So that'd be, yeah, not equal to.
Second one, yeah. Okay, and then the value of the test statistic I got was 1.458, so it'd be the last one. And the p-value I got was the last one, 0.145.
Okay.
And so we failed to reject because 0.14 is greater than 0.05, right? So
Right.
second, the last one. And then the next one, that's where I was starting on. So for the first answer, I got 6.580 because that was a
Okay.
chi test. And then the next one I got is 0.087, which is the last one. And I put no, the p-value is greater than 0.05, so second to last one. And then we have insufficient evidence to say, oh, I don't think that I saw that as the question. I thought the next one was no, I failed to reject. So we would say what? We have insufficient evidence to say that being a morning or night person is independent.
Yeah.
Right?
Second
Is
one.
independent? Second one.
Yeah.
All right, that's as far as I got. I just started on this one. I think I got the confidence interval, I got 0.19 and 0.310. So that's the third one.
Okay.
That's where
I
I
have to ask
stopped.
you, how did you do this one? This is where I.
This one was the, hang on, which one did I do? Hold on a second, let me look.
Oh, you're good.
This one was the one proportion test. So your X is 50,
Oh, okay.
and the N was 200, and the null hypothesis was the 20%. Because that's the question on it. Suppose you had been in charge of designing the study. What sample size would be needed to construct a margin of error of 2% with 95% confidence? So this is we got to figure out the calculation, right? For the margin of error. I got to find that formula. Okay. No, wait. Okay, N equals suppose you've been in charge of designing the study. Okay, so we have the prior estimate. So if we have a prior estimate, it's N equals Z divided by M squared. So
Okay, yeah. So it'd be point.
N equals P. Is that right?
Yeah. So it'd be point. The Z, so 1.96 divided by 2 times.
1.96.
Or not 2 times. Oh yeah, because you can do Z over 2M squared.
Yeah, but that's if you don't have the prior estimate. We have the prior estimate because it's that 0.2.
Oh, okay. So Z 1.96.
Divided by the margin that we want, which is 0.02.
Yeah.
I feel like I'm missing something.
Is it 0.02 or is it? Oh yeah, because it's 2%. Okay.
Right? So where does the 0.2 come in? Where does the prior one come in?
And then you do P.
Oh, that's where it comes in.
Yeah. So then you do
P times 1 minus P. So it'll be 0.2 times 0.8.
Yeah.
It'll be 0.16.
So 9604 times 0.16. I got 1536.64.
Okay, so it's the second one.
Yeah.
Okay, suppose you wish to see if there is evidence that graduates on one of the top 10 business programs performs better than other investment managers. Conduct a hypothesis test. Use a level of significance of A equals, okay. Which of the following pairs of hypotheses is the most appropriate? So, HO, P equals.
Is
Is this
performs
based
better,
on
so
our
would that
previous
be?
data? Oh yeah, it's from our previous data, okay.
So would it be the third one down?
Performs better than, see, evidence is the graduates of one. So P equals 0.2. Great, yeah, I think so, greater than.
Yeah.
How many measurements must you have in order to assure that P hat is normally distributed? Isn't that the third one?
Yeah. Yeah, I
the
just read that the
test?
10.
So the value of our test statistic is, all right, let me see if I can calculate that. Is that all the same data we did earlier with the 50 and 200?
I think so.
Because we did it based on the 0.2 for the 20%, right?
Mm-hmm.
Because the test statistic I got for the one in the earlier question is, let me see, 1.768.
So So the first one?
Yeah. And the p-value was, because it's a greater than, so it's one-sided, the p-value is 0.039.
Okay.
Is there sufficient evidence to conclude that graduates perform better than other investment managers? Yes, because 0.039 is less than the level of significance.
Right.
So yes, I rejected the first one, right?
Rejected. Yeah.
Ugh.
Oh
Okay.
my gosh.
Oh, we had this question on a previous test. I remember this blue thing.
Oh yeah.
To compare Pharaoh's ability, Cohn took a random sample of 100 blocks, each of which contained 300 sentences, and used. Well, so we have to do this in SPSS.
All right.
So this doesn't feel to me like it's all about the proportions part that we were doing, though. This
No,
feels
it's
like everything.
I don't know. Weird. Yeah, is this like a final test?
That's what it feels
'Cause
like.
I don't remember seeing anything else.
Okay, let's see what we get. I gotta open it up. Hang on just a second.
Yeah, me too.
I haven't studied. I have to refresh myself on SPSS now. Okay. He wants to use this data to see if it differs from the mean blue score of another leading translation software, which has a population mean score of 0.295. See if this data differs. So isn't that a one sample t, and then we use the 0.295 in the one box?
Yeah.
Do like
Come on. Come on. So just doing a one sample t-test for this bad boy?
that's what I'm trying, and then put the test value as 0.295 and see what. It just seems like that can't be right at this test that we're at.
Right.
Okay. So the confidence interval that I got is negative 0.01262 and upper is negative 0.00216.
That works. My thing is everything is taking so long to load that by the time I get there, it might be too late.
So I have
So,
no idea if that's right or not. I feel very unconfident with this. But we can put the
Reading it,
number.
I think you're right. I mean,
Okay,
I don't know
so
what else you would do in this situation.
we can put the numbers in. We'll just see how our grade is. I mean, if it's bad, it's, we'll learn from it. So negative 0.0126. So that would be negative 0.013, right?
So this is the
The
negative
lower.
0.0126, and then
And then
yeah,
negative,
so 1B.
and then negative 0.002 is the upper. Okay. So negative 0.013 and negative 0.002. Degrees of freedom is 99. And what does it want next?
The T.
Negative 2.803. Calculate the p-value for a test of, okay, not equal to. So p-value, whoops,
Two-sided.
my computer is acting so weird. Okay. P-value, we're doing not equal to, right?
Right. So it'd be
So
two-sided.
the two-sided it gave is 0.006. All right. Based on the results of this test, we would conclude we have sufficient evidence to say the true mean is different than 0.295, right?
Yeah.
So it's the last one. So the last thing we have is what?
Doing the differences of AM heights. I wish we had saved where it was probably the numbers and stuff.
I just think it's so
'Cause
weird.
we
We did
did
this.
AM PM heights, right?
Yeah, we did this stuff already.
Yeah, this must be the last test. I hope.
I think we still have a final.
Do we still have another final too?
I think so. All right, let me open this other file. AM, PM heights.
Come on, computer.
So on this one, I have to remember how to do all of this. We need to data. We have to add, how do we add the column?
Or subtract them from each other.
Yeah.
So I'm trying to remember. I'm looking down
Completely
at a little
blank.
drop down.
Compute variable? I think it's compute variable under transform.
Okay.
Yeah. We put difference there. And then we put, what's the question that it's actually asking us?
Let's see.
If morning is different than night? Taller in the
You
morning.
find the difference as AM height minus PM height.
Okay. So we want
So
to do height in the AM minus height in the PM. Okay.
okay.
Okay, then we have our difference. And then we're doing everything off of the difference.
Right. So you
So
do analyze.
we're doing analyze, and we can still do a one sample t because we're only doing it on the differences.
Right.
And the question, does the question have a test statistic? No.
Let me look real quick.
This is just the same thing we already did before on the other test, right?
Yeah.
It looks like. Okay, so
90
differences. Okay. Let's see what we get. So what questions does it ask us? 95%
As for the lower and upper,
confidence interval.
that, yeah.
So for that, I got 8. The lower is 8.728, and the upper is
Yeah, that's what I got.
10.455.
That is what I got.
8.728 and 10.455. Okay, and test statistic, I got 22.446.
Yep, that's what I got. And then a difference of 40.
Mm-hmm. .466. Come on, computer. Degrees of freedom is 40. 440.
Yeah.
Degrees of freedom of 40. P-value of zeros. Is that what you got?
Mhm.
0.000.
Yep.
Okay. And so, is there enough evidence to suggest they're taller in the morning than in the evening? Yes, because we
Yes,
rejected the null,
rejected the null. Yep.
right?
Yep.
Okay. You want to submit?
Not really, but have to.
Let's make sure we don't have any blank questions.
Yeah. I think we answered them all.
I think we did too. I'm just scared to actually submit it.
I know. I'm not ready to take a test on a Wednesday either.
Is it due on Wednesday?
I think it's due tomorrow.
Be quiet. Are you serious?
Yeah.
I have not even studied. Okay, let's submit this bad boy.
All right.
Well, not terrible. What did we get wrong? Let's see.
5. So I wonder if that was C.
Oh, that's the one we changed.
Yeah.
Darn. Okay. And 7. All right, so I'm
A.
gonna have to do those tables. I can see that right now. Oh, and our thing was wrong on
15.
15. Huh.
I have to go back and redo that one.
Yeah, I'm gonna have to look at that one again. But the scores were right, but they're saying that the confidence intervals were wrong.
Yeah.
Okay, I'll have to go and see what I did wrong on that.
And 23. So 23 should have been because it was not dependent on age.
I guess so. I'm gonna have to look back at that. No, I'll do that when I do the table.
Yeah.
The null hypothesis. And my blue was wrong. How is that wrong? Everything else was right, but the confidence interval is wrong.
Yeah, that
It's
doesn't make
all on the
sense.
it's all on the same output. Let me go up and look at it again. Blue scores. Negative 0.0126 would have been 0.013 and 0.00216. Huh. I don't know how we got that wrong. Maybe we needed a
Either.
0 in front of it?
Let me look again.
That's not what it said, though.
Yeah, it's showing the exam is tomorrow.
Really?
Yeah.